All right, now we had one of the easiest topics in grade 12 physics. I don't know if this is difficult for you, but momentum and impulse, one of the easiest topics. Okay, well, the easiest topics in grade 12 physics are momentum and impulse. I'm not usually saying them in the correct order. I'm not saying momentum and impulse is the easiest. I'm saying that it's one of the easiest. So we have momentum and impulse. We have for the electric effect, we have Doppler effect. What else do we have? Um, yeah, those three topics are the easiest in grade 12 physics. The other ones are a little bit challenging. They're not even straightforward. You have to think critically before you get to the correct answer and everything. But those three, well, not actually three, four. We have momentum and impulse, we have Doppler effect, we have photoelectric effect, and then electrodynamics. I almost forgot about it. So there's four topics that are easier in grade 12 physics. And the other five topics, well, they're not really that easy. But I'm gonna be here anyway to the rescue. Right. So I'm gonna be rescuing all the learners that are struggling with these topics. This is one of the easiest topics. That is why it is only given about 10 marks. So this question was question 4, and you know that we're still doing grade 12 physics paper 1 2019 November paper, and now we are doing question 4, which is momentum and impulse. This question was only just 10 marks, so I'm not gonna spend too much time doing this question, but I hope that you're still gonna enjoy it anyway. Let us get into it. So it is said a bullet moves east at a velocity of 180 meters per second. It hits a wooden block that is fixed to the floor. The bullet takes 0.01 seconds to move through the stationary block and emerges from the block at a velocity of 80 meters per second east. See the diagram below. Ignore the effect of air resistance and consider the block bullet system as an isolated system. And of course, they've given us the scenario and diagram and the direction as well. So let us usually just draw this. I'm not even going to need to pause right now. I'm going to take my time. This is one of the enjoyable topics, even though it is one of the easiest. Right, so we have a fixed wooden block here. This is the fixed wooden block. Of course, I'm not going to draw beautifully or accurately. Right. And then we have a bullet. And then we have a bullet that is traveling at 480 meters per second. Yo, that is fast. And then it is going to emerge. That piece is going to go through the wooden block at 80 meters per second. And then we also have the directions. Right is east, up is north, down is south, and left is west. Right, what else do we have? Okay, well, they say that it is fixed to the floor. So we have a floor here. And when they say that it is fixed, they mean that this wooden block is not going to move at all. Okay, so words like fixed or embedded, they both mean the same thing. And they mean that this, it is not moving at all. Okay, so this is not moving at all. It's not going to move at all. It's going to remain stationary until the end of time. Right, so the only thing that's going to move here is the bullet. So the bullet is going to go through this wooden block. So this is the wooden block, the fixed wooden block. This is the fixed wooden block. So the bullet is going to go through this wooden block. I don't know what that's on right there. And this is the bullet going through. This is the bullet going through. So the bullet's gonna go through this wooden block. Okay, well, they're saying a bullet moves east, so it's gonna go to the right at a velocity of 480 meters per second. So that means this is the initial velocity of the bullet. It hits the wooden block that is fixed to the floor. So when they say it hits, that means this bullet is gonna apply a force on the wooden block. But since the wooden block is stationary, it is just not gonna be relaxing. It is also gonna apply a force on the bullet. So the force that the wooden block is gonna apply on the bullet, it is the one that is going to cause a decrease in speed of the bullet. So as the bullet and the block collide, they're going to collide with each other. That means the bullet is going to hit the wooden block. So as they collide, they're going to share energy. So because the bullet is moving, that means it has a very high kinetic energy. Remember that kinetic energy is half mv squared. So since the bullet is moving, that means it has an initial velocity. And its initial velocity is 480 meters per second, right? So imagine if we square that. How much do you think the kinetic energy is going to be? It is going to be enormous. Let us actually calculate the kinetic energy of the bullet just for the fun of it. So we're going to be that the kinetic energy of the bullet is equal to half the mass of the bullet. Did they give us the mass of the bullet? No, they didn't give us the mass of the bullet. So the fact that we don't have the mass of the bullet, we cannot calculate the kinetic energy of the bullet. But we can actually imagine that regardless of the mass of the bullet, we're still going to get a very high or a very large kinetic energy of the bullet. So the bullet has a very large or a very high kinetic energy. Right. So since it has a very high kinetic energy and the wooden block is stationary, so the fact that the wooden block is stationary, it means that it has a potential energy. So it has some energy stored in it, but it is not going to express it because it is stationary. You can only express or expend your energy with movement. So that means if you don't move, no energy is going to be lost from you. The very same way when you run, you get tired. You get tired because we're moving. So as you move, you expend or you lose energy. That energy that you're going to lose, we call it the kinetic energy. So that is what's going to happen to the bullet. So this bullet is going to have the kinetic energy, its initial kinetic energy. And as it goes through the wooden block is going to absorb some of this energy. Not really absorb, but you know what I'm saying? That is the term that I'm just going to utilize for this scenario, right? So the wooden block is going to have some of that energy from the bullet. So the bullet is going to transfer some of its energy. So as it loses energy, it is going to lose the energy to the wooden block. So like we know that according to the conservation of energy, energy cannot be created nor destroyed. It can only be transferred from one object to the next, or can be only changed from one form to the next, right? So the energy that the bullet had initially, it is going to be transferred. It's going to be the bullet is going to lose that energy to the block. So the block is going to be receiving that energy, and then the energy of the bullet as it goes through is going to now be less than. That means the energy initially, the kinetic energy of the bullet initially is going to be less than. It's going to be greater than. Sorry, it's going to be greater than the kinetic energy of the bullet finally. So the initial kinetic energy of the bullet is going to be greater than the final kinetic energy of the bullet. I know that I'm doing a lot of analysis. I'm not really just doing the analysis, I'm also teaching you at the same time. So as we go through this question and try to answer these questions, and you see how we tackle this type of questions, I also have to teach you or remind you, or we have to do some revision of the theory, right? So the kinetic energy of the bullet initially is greater than the kinetic energy of the bullet finally, because some of the energy that the bullet has lost is going to be lost to the wooden block. That means the wooden block is going to absorb or gain or receive that energy. So I hope that you understand that. The very same way when you push a trolley. Remember that the trolley was initially stationary when you get into ShopRite, Woolworths, and so on, right? So when you get into the grocery store, the trolley is going to be stationary. You're going to find the trolley stationary, right? And you're going to push it. You have the kinetic energy because you have 18 and all of those, right? So you have the energy. So you're going to push the trolley. As you push the trolley, you are going to lose some of this kinetic energy. The fact that you are feeling yourself pushing the trolley means that you are actually losing energy. So that feeling that you are feeling, it is because of the loss of energy. So as you add more and more and more objects in that trolley, the trolley becomes heavier. So now it requires you more energy. That means more force to push the trolley forward. That means the heavier the trolley, the more energy you lose. Okay? So that is how beautiful physics is. But we're now applying it in momentum and impulse. Right. So as the bullet goes through the wooden block, it's going to lose the energy to the wooden block, and its final kinetic energy is going to be less than the initial kinetic energy. So that is why the final speed of the bullet is less than the initial speed. So I hope that part you understand. Right, but since this wooden block is embedded or it is fixed to the floor, it is not going to move. It is just going to take that energy in. So maybe we're gonna see that by maybe a fire or a smoke, something like that. You know, so that is going to be that energy that the bullet has lost. Maybe we're going to see this. We're going to hear the sound. So that's what we call the sound energy. So that energy that has been lost by the bullet, we're going to see it in other forms. Maybe sound, maybe smoke, something. You know what I'm saying? Right. So now that you understand that part, they're also saying the bullet takes 0.01 seconds to move through the stationary block. So this bullet is going to go through the block, but it's going to spend 0.01. So the time that the bullet is going to spend through the block is 0.01 seconds. I hope that we're still on the same page with that, right? So it's going to take 0.01 seconds to go through the wooden block. I don't know how long the wooden block is. Maybe we're going to need to know its length. Right, they're also saying, and it emerges from the block at a velocity of 80 meters per second east. So it is still going to go east. So this is its initial velocity, and this is its final velocity. They're saying to us, ignore the effects of air resistance. Of course, as the bullet is flying, and before it goes through the wooden block, it is going to experience resistance, air resistance. But they're saying to us, ignore that. Pretend it is not actually happening. So we're going to pretend there's no air resistance at all. And they're saying, consider the block bullet system as an isolated system. What is an isolated system? Remember that we have 3 types of system. Now this is a lesson. This is not just me answering the question. This is me also giving you the lesson. So you're very, very lucky. Consider yourself fortunate. So we have 3 types of systems. We have an open system. First, we have an isolated system. So we have an isolated system. We also have a closed system. We have an open system. So with an isolated system, there is no exchange of anything at all. Anything whatsoever. There is nothing. There is no exchange of anything at all. That means there is no exchange of matter nor energy between the system and the surroundings. So if we talk about the system, we also have to talk about the surroundings. So if the system is isolated, that means it is separated. It is independent of the surroundings. All right? There is no such thing as that in the world that we are living in. But in the question paper, you're going to have to imagine that. All right, so if a system is isolated, that means that there's not going to be any interaction of the system and the surroundings. There's not going to be any exchange of matter nor energy. both of the matter and the energy are not going to be exchanged between the system and the surroundings. Let us go to the closed system. With the closed system, if a system is closed, then there's going to be an exchange of energy, but matter. So the system and the surroundings are going to only have a relationship in regards to the energy, not the matter. So they're only going to exchange, trade the energy and nothing else other than that, right? So they're only going to exchange energy and not the matter. What about the open system? The open system is going to allow everything. Because it is open, it's going to allow everything. So it's going to be a full exchange of both matter and the energy. So with the open system, if we say that a system is open, then there's going to be an exchange of matter and energy between the system and the surroundings. So I hope that that is clear. So an isolated system is where there is no exchange in anything at all, whether it's matter or the energy. So in physics terms, we say that an isolated system is a system which there is no external force causing an effect on the things that are part of that system. If we have an object that is part of that system, there's not going to be any external forces causing an effect on that object in that system. I hope that that is clear. So that is what an isolated system is. No external forces are going to cause an effect on whatever that is part of that system. Right. So yeah, that is all that we have, and we don't actually have anything else. So that is my full analysis of this question. I hope that you have actually enjoyed me doing the full analysis of this. I have not actually done a full lesson on this momentum in this particular video, but if you'd like to join my classes, then you're welcome. Because when you join my classes, you're going to receive full lessons regarding all of these topics. Right? Everybody's welcome, and you're welcome to join at any time at all. So I'll be expecting you, and I'll be so glad to welcome you in the LAMLEE Math tutoring services. Right, now let us get into the questions. But one more thing before we get into the questions. I have not talked about the momentum and the impulse. That is one thing that I've just remembered. Let us talk about the momentum and the impulse of this bullet, and maybe of this wooden block. So let us talk about the momentum first of the bullet. So initially, the momentum of the bullet, what was it? So the initial momentum of the bullet, Pi, is going to be equal to the mass of the bullet multiplied by the velocity initially of the bullet. And the final momentum of the bullet is going to be Pf, which is equal to the mass of the bullet multiplied by the final velocity of the bullet. Of course, we do have the initial and the final velocities of the bullet, but we don't have the mass. So we're not going to be able to calculate the momentum, unfortunately. What about the impulse? With the impulse has this formula. It is F net delta T is equal to the changing momentum, or F net delta T is equal to M, then Vf minus Vi. We can neither calculate nor determine the impulse because we don't have the mass. Of course, we do have the final velocity of the bullet and the initial velocity of the bullet, but we don't have the mass. So the fact that we don't have any mass, of course we do have the time, right? We do have the time. We don't have the mass. So that means things are not actually making sense. The other thing is, what about the F net? The F net is, what is the force, or what is the magnitude of the force that the bullet is going to exert on the wooden block as it goes through? And what is the force that the wooden block is going to exert on the bullet as the bullet is going through? So that is what you're going to call the F net. By the way, the F net, well, let me say the impulse that the bullet is going to exert on the block is going to be the same in magnitude, but it's in opposite direction as the impulse that the block is going to exert on the bullet. So that means we're going to apply Newton's third law in this scenario. So the amount of force, or the magnitude of the force that the bullet is going to exert on the wooden block is going to be the same, just in opposite direction, as the amount or magnitude of the force that the wooden block is going to exert on the bullet. So I hope that that is clear. So we cannot determine the impulse nor the momentum because of the mass. We don't know the mass of the bullet. Right. Now let us get into the questions, because we have done our full analysis. We have talked about almost everything, including the momentum and the impulse. Right. So 4.1 says, let me actually write it down here. 4.1 says, explain what is meant by an isolated system as used in physics. Fortunately enough, I have already explained what isolated system is. So I'm just going to write it down. So an isolated system is a system which there is no external forces causing an effect whatsoever. Causing an effect or acting. Sometimes people say causing an effect or acting on. Right. The other people could actually say, well, this is in terms of physics, but maybe in terms of chemistry. In chemistry, we also do the isolated system. But isolated system is an isolated system, regardless of whether we're doing chemistry or physics. So this is a physics, I guess, explanation or definition of an isolated system. But in chemistry, we would say an isolated system, I'm not sure, but I believe that if you define it utilizing the chemistry terms, you're still going to get it right because isolated system is still isolated system. But I actually doubted that because they said as used in physics. So I don't want you to write the chemistry definition of an isolated system and get it wrong and say that you got it from me. So please, I'm not saying that this is also applicable in this type of question, but I'm saying that an isolated system also have another definition, which is an isolated system is a system which there is no exchange of matter, no energy between itself and its surroundings. So this is a chemistry definition of an isolated system. If it happens that you get lucky and they still make it correct, then of course you're welcome to write this. But I don't usually recommend that you write this. I don't usually advise you to utilize this definition because this is a chemistry definition. So because they said as used in physics, please stick to this one. Right, let us go to the next question, which is 4.2.1. It is the second last question for this video. I just wanted this video to be about 25 minutes. That is why I kept on talking and tried to make it a lesson, right? I just love teaching. So yeah, if it happens that you are struggling with physics or mathematics, chemistry, like physical sciences or mathematics in general, then you're welcome to my classes and we're going to go through all of these topics together, and I'm going to make sure that you understand them thoroughly, and we're going to have fun doing math and physics and chemistry together. All right, any topic at all, whether it's mathematics, Euclidean geometry, analytical geometry, statistics, electricity, electrostatics, any topics at all, like electrochemistry, any topic at all, okay, as long as it's within mathematics and physical sciences. Right, let us get into this question 4.2.1. So it says, well, before we get into 4.2, there's an information that I've been given, and it says the magnitude of the momentum of the bullet before it enters the block is 24 kilograms meters per second. Okay, well, they've given us the momentum. Isn't that amazing? Right, so we talked about the momentum, initial momentum. Right, so they've given us that. So they're saying that the initial momentum, well, they didn't actually say initial momentum, but we already know that they're talking about before it enters. So before it enters the wooden block, that is its initial momentum. So they're saying that its initial momentum is 24 kilograms meters per second. Now that we have the momentum, we can determine the mass, because we said that we don't have the mass. We do have the initial velocity, we don't have the mass, and of course we don't have the initial momentum. But now they've given us the initial momentum. That means we can calculate the mass of the bullet. Now that we have the mass of the bullet, we can calculate the final momentum of the bullet, and after calculating the final momentum of the bullet, we can also calculate the impulse. And we can also calculate the net force that the bullet is going to exert on the wooden block. So that means the fact that they've given us this hint, we can calculate everything else that was mysterious before, that we didn't know before. Right, now let us calculate the mass. So they're saying that initial momentum is equal to 24 kilograms meters per second, right? So we're going to be like, we're looking for mass. Its initial velocity was 480. Okay, well, because this is momentum and impulse, and momentum is a vector quantity, we also have to make a choice of direction here. The very same way we did with the Newton's laws and the vertical projectile motion. We also have to make a choice of direction. As long as we're dealing with mechanics, that means Newton's laws, vertical projectile, momentum and impulse, and work, energy, and power. We have to make a choice of direction. Whether we're taking up as positive or down as positive, or we're taking right as positive or left as positive, or we're taking east as positive or west as positive, or north as positive or east south as positive. Right. So I'm going, well, if you are part of the LAMLEE tutoring services, you're going to know that I'm always taking right as positive or east as positive and also up as positive. So we're going to take east as positive. So since it was initially, this bullet was initially going east, that means we're going to substitute the positive velocity, because its initial velocity was when the bullet was going east, which we're taking as positive. That is why it's going to be positive. So what we're going to do, because we're looking for mass, we're going to divide both sides by 480. Therefore, the mass of the bullet is going to be equal to 24 divided by 480. I know that 24 divided by 48 is half. So I'm going to multiply half by 0.1, which is going to be 0.05. Don't ask me how I got that. Kilograms. So 24 over 48 is equal to half, which is 0.5, but this is 48 multiplied by 10, so we have 1 over 10. So 1 over 10 is 0.1. So when you multiply 0.5 by 0.1, you take the comma to the left once, so that's going to be 0.05. That's how I got it. I know that there's certain people who are curious, who is like, where did you get the answers from? So that is how I got the answer, right? So the mass of the bullet is 0.05 kilograms. That is how we answer 4.2.1, the mass of the bullet. Right, 4.2.2 is saying calculate the average net force exerted by the wooden block on the bullet. Simple, because we already had an idea of how to calculate the net force. We have pretty much everything. We have the time that the bullet spent in the wooden block. We have it as 0.01. We have the mass, because we calculated it. We have the final velocity, that is 80. We have the initial, that is 480. Now we can calculate the force that the wooden block, the force that the wooden block exerted on the bullet. They're not saying the force that the bullet exerted on the wooden block. I'm saying the two forces, the force that the bullet is going to exert on the wooden block is going to be equal in magnitude, but act in opposite direction as the force that the wooden block is going to exert on the bullet. So they're going to be the same in magnitude, but in opposite directions. That's what we call Newton's third law. But they want the force that the wooden block exerts on the bullet. So since the bullet was going to the east, that means its motion was positive. So since the wooden block was exerting a force to slow down the bullet, decreasing its velocity, therefore that force that the wooden block was exerting was to the west. Because we're taking east as positive, we're going to get a negative force that the wooden block is exerting on the bullet. So you must get a negative force. Let me explain that again. I know that there's certain learners which they've actually got this SME score. They didn't actually hear what I said. Let me explain it again. Right. So we're taking east as positive, and the bullet is going to the east. So that means its motion is positive. Of course, this bullet is going to exert a force on the wooden block. We don't want that force. We don't want the force that the bullet exerts on the wooden block. We want the force that the wooden block exerts on the bullet. So since the bullet was going to the east and we take east as positive, its force is going to be positive. But we want the force that the wooden block exerts on the bullet. That means the force which is going to slow down the bullet, decreasing its velocity. That force is going to be exerted by the wooden block on the bullet. So that force is going to slow down. It is going to act like friction. So it's going to slow down the bullet and it's going to be acting to the west. So since we're taking east as positive, that force is going to be acting to the west, the force is going to be negative. So the force that we're going to calculate here on 4.2.2, we must get it as negative. If we get it as positive, there must be somewhere in our calculations where we did things wrongly. Okay, I explained that twice. So I hope that it is clear now. So let us calculate the force. So we're going to be like F net, which is that force, delta T, which is this thing that we see here. This thing, we call it an impulse. F net delta T, this thing that we see here, we call it an impulse. And its symbol is Newton's second. Actually, not Newton's per, it's Newton's second. So it's NS, not natural sciences. It's Newton's second. Okay, so this is the SI unit for impulse. So I hope that is clear. Right, so we're going to be like the impulse is equal to the change in momentum, which is m mass multiplied by the final velocity minus the initial velocity. Right, so we're going to be like the F net that we're trying to calculate multiplied by the time that the bullet spent is 0.01, which is equal to the mass, which you calculate to be 0.05. The final velocity of the bullet is 80 minus initial velocity of the bullet is 480. I know that these calculations are very confusing to some of the learners. They don't understand they like the science. They don't understand what is happening with the science and everything. The science are very simple. When I say the science, I'm not talking about this science. These are homophones, by the way. This science and this science, they are homophones. This is what we call homophones. Now I'm doing English. Anyway, I'm not talking about this science. I'm talking about this science, okay? So certain learners don't understand what is happening with the science. Sometimes they say negative, and they get it wrongly and everything, right? So this is how we do the science. We have to make sure that we make a choice of direction. So since I personally have taken east as positive, every motion that is going to the right or east is going to be positive, and every motion that is going to the east or left is going to be negative. Right, so look at what we are doing. We are calculating the net force, right? So let us look at the final velocity and the initial velocity of the bullet. So the final velocity is 80 meters per second. That is its magnitude. What is the direction? The direction is to the east, and we're taking east as positive. So that is why we are written positive 80. Positive 80. Then the minus of the formula. This minus is not of 480. It is the minus of the formula. What about the 480? 480 is the initial velocity. It is the initial velocity of the bullet, but it was going to the east. So the fact that it was going to the east, we're going to write the final velocity, the initial velocity as positive. So that means we have positive 80, which is the final velocity going to the east, minus of the formula, then plus 480 because initially was going to the east. So negative multiplied by positive is still going to be negative. Let me write that neatly. So we're going to have F net 0.01, which is the time is equal to the mass, which is 0.05. Initial velocity was 80, which is positive because it was going east, then minus of the formula, then final velocity was also, initial velocity was also positive. Positive what? 480. Why positive? Because it was initially going to the east. So this is what we have. I know that certain learners don't understand the science. So these are the science then. Okay? So I hope that this is clear. Final velocity was positive, that is why positive 80. It was positive because it was going east. Initial velocity was also positive. So that is why I've written it as positive. It was going east. Then this minus is of the formula. Okay, so that is why we have 80 minus. This minus here, I'm not saying that it was going to the west or the initial velocity was negative. No, it is the minus of the formula. So I hope that is clear. Because I know that a lot of learners, they confuse the signs. But since we're looking for the the average net force, we're just going to divide both sides by 0.01 seconds. Divide by 0.01 seconds. And we're going to press the whole thing into the calculator and determine what the net force is. So the net force is going to be equal to, I don't usually have any space at all, so I'm just going to write it here. So I'm so sorry. F net is going to be equal to, then I'm going to press it into the calculator, and that is going to be the end of the video. Allow me to do that. I'll be back in a second. So after pressing the calculator, I get the net force to be equal to, well, it is going to be negative, so I get, where do I write it at? I don't got any space. Let me see. Let me shift my camera a little bit down so that I can actually show you what the answer is, please. All right, now this is better. So F net is equal to the whole thing. So I get it to be equal to negative 2000 newtons. Why is it negative? It is because it is the force that the wooden block was exerting on the bullet. So it is acting to the west, and you're taking east as positive. That is why we get a negative value. But what did they say? They said calculate the magnitude of the average force. Okay, so we can actually say F net is equal to 2000 newtons, then westward. So it was going to the west because it is the force that the wooden block was exerting on the bullet, so it is westward. But the force that the bullet was exerting on the wooden block was the same magnitude, 2000 newtons, eastward, because the bullet was going eastward. So the magnitude is the same, just that they're acting opposite directions. So we're either going to write negative 2000 newtons or 2000 newtons westward. So this is the answer for 4.2.2, and I hope that you have actually understood how we have tackled these 3 questions, and you have enjoyed me doing the full analysis, and you love momentum and impulse. And if you don't understand the topic, then you're welcome to join my classes. All right, so thank you very much for watching this video so far. The next video is going to be question 5, which is going to be about work energy and power, and that is going to be part 6 of the series of this paper. So we're going to take the whole paper until we're done with it. So every day I'm going to post a video of each part of this paper, and now we're done with question 4, which is part 5, and the next part is going to be question 5, work energy and power. So please stay tuned for the next videos that are going to follow. See you in the next videos. Thank you.